So let's review trig graphs. Again, the sine function starts at 0, 0. It goes up to 1, down to -1, and back to what we call, I guess, like its starting point again, every 2 pi. The period of sine is every 2 pi. Cosine function actually starts up here at 0, 1 instead of 0, 0. And it goes down to -1 and back up to 1 to the starting point again. The period is every 2 pi, which means every time you go around the unit circle, it starts back over. Again, this is the formula for how to graph based off of the vertical stretch, the horizontal stretch, which again, we discuss as a period, the horizontal shift, and then the vertical shift. So again, let's do some review of this. So to describe this transformation, it is the number that is in front. And so we would call this the amplitude of 4. And we wouldn't necessarily say an amplitude of -4. We would actually say an amplitude of 4 and a reflection across the x-axis. Okay. We also could say that it is a vertical stretch of 4 and reflection across the x-axis. The period is the formula, which is 2 pi over b. And again, the b is 1/2, so 2 pi over 1/2 is 4 pi, which means the sine function will go up, down, and back to a starting point every 4 pi units instead of every 2 pi units. A phase shift, you're going to take the entire parentheses and you are going to set it equal to 0. You would add pi over 3 to both sides and divide by 2, and you'll get pi over 6, which means you would say that it is a shift to the right pi over 6 units. Make sure that you do say whether it's going left or right. Since that's a positive, you're going to the right. Or you could even say horizontal shift. And then this one, it is because this number is on the outside, you would say that this is a vertical shift down 4 units. It's negative, that's why you would say it is down. So let's actually try to graph this. So here's what we're going to do. First thing I'm going to do is I'm going to go ahead and graph the original. This is sine, which means it starts at 0, 0, and it reaches 1 at pi over 2. It reaches 0 at pi. It reaches -1 at 3 pi over 2, and at 2 pi. So that is the original sine. Next, we are going to go ahead and do the period shift. Well, first, let's go ahead and actually do the period. So we know that A is 1, which means we don't stretch it up or down any. We know B is the period, which is 2 pi over B, which means it's 2 pi over 2, because the period is the number in front of x. So the period is pi. That means it is going to go up, down, and back up every pi. So it's going to go up, down, and back up every pi. Up, down, and back up every pi. That is B. And now we're going to do the shift. So C, that is where we're going to take the entire parentheses and we are going to set it equal to 0. which means we're going to add pi over 2 to both sides, and then divide by 2, which is pi over 4. That means it is going to shift right pi over 4, which means, so we're here at the pink. So this is going to shift to pi over 4. This is going to shift over, because each of these units is pi over 4. So I'm going to take each section where it crosses like 0 or crosses at 1, and we're going to shift it over pi over 4. Shift over pi over 4. Shift over pi over 4. So now it is going to be, so it's going to go here to that one, to that arrow, to that arrow, to that arrow, to that arrow, to that arrow. And last is D, which means it is going to shift up 3. So we're going to take the green dots and move them up 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And we can now graph. And that roughly is going to be how to graph this sine of 2x minus pi over 2 plus 3. Now we're going to write an equation. So we're going to go in the opposite direction. We are given the graph, and we're going to do it. Now the first thing is, because sine and cosine can actually look like each other, we first have to know, what are we graphing? This was a cosine function, okay, which is great. Cosine starts at 0, 1 normally. So I'm going to actually graph. So a normal cosine goes down and back up every 2 pi. Down and back up every 2 pi. Down and back up every 2 pi. Okay. So I realize that instead of it being, it looks like this shifted up 1. So it does look like it did shift up 1. Because if you look at what we call the midline, if you look at that midline, if you put it in, if you cut it in half, then it went up. The midline here went up 1. Okay. Next, it looks like the period is different. It didn't look like it shifted, because it does, the highest point does start at the same place, so there is no shift, but the period has changed. This period goes from down back to up every 4 pi. So it starts at the top and it gets back to the top every 4 pi instead of every 2 pi. So what I'm going to do is, I know that the period should be 2 pi over b. And we can now see that this graph has a period of 4 pi. So I'm actually going to set it equal to the period of 4 pi, and I'm going to solve. So b times 4 pi equals 2 pi. So I'm going to divide both sides by 4 pi, and I will get 1/2, which means 1/2 is going to be in front of cosine. So I believe, therefore, our final answer is going to be cosine of 1/2 x plus 1. Okay? So let's look again. This is a sine graph. So the first thing I'm going to do is, I know that sine starts at 0, 0, and then it's supposed to go up and back down every 2 pi. This midline, if you were to cut this function in half, it went up 1, which means we know that it is going to be sine plus 1. And now we're going to look at the period. So the period, if it starts here, it goes up, down, and then back to the starting position every 2 pi over 3. So the period is 2 pi over 3. So I'm going to do that. We know that the period is 2 pi over b, because that's what we're looking for is b. And since we know that 2 pi over b is the period and the period is 2 pi over 3, that means b must be 3, which means that must be a 3x. So that means our final answer is going to be sine of 3x plus 1. Okay, we are going to write a cosine function, again, looking at cosine, and the original cosine graph starts at 0, 1, and it goes down at pi, back up, and starts again at 2 pi. But this graph goes up to 3, but down to -5, which means it shifted. You're trying to find the midline. So 3 is the highest, -5 is the lowest. So to find the midline, basically like a midpoint, you add and divide by 2. You're finding the average. -2 over 2 is -1, which means this line, the midline, the halfway to basically to cut it in half, is happening at -1. That is automatically going to be your vertical shift. So we know it is cosine of something, and it is going to be a -1. And now that we know the vertical shift, we know this is the midline, now we can determine the stretch. It stretches up and it stretches down 4. It goes 4 units up from the midline, and it goes 4 units down from the midline, which means there is a 4 in front. And then we want to look at the period. It starts at the top, it goes down and back up at the top every 2 pi, and so actually the period is normal x, so therefore that is going to be our answer. 4 cosine of x and then a -1. The period is 2 pi, and there is no shift because it starts at the top where it's supposed to, goes down and back up every 2 pi. So let's try one. Okay, this is a sine graph because clearly it's sine. It starts at 0, 0, and it goes up, down, and back up. That's where the starting point is again, at 2 pi, which is great. That means the period is exactly what it's supposed to be. That is a normal period, which means it's going to be just a 1. And it looks like everything just shifted up 1, it shifted up 1, it shifted up 1, it shifted up 1. So it looks like everything just shifted up 1, but it didn't stretch any. You're still going up 1 and then down 1. If you look at the midline, it looks like you just went up 1 and you went down 1. So there is no stretch. So that also should be a 1. So let's try it. So let's check to be a 1, 1, 1, and hit enter, and that is correct. Okay, this is a cosine. It looks like it's the exact same function of cosine. It's the exact same graph. It looks like it just moved the entire graph up 2. So I'm thinking that everything is what it's supposed to be, except that it moved up 2, which is, all right, this one's a little bit different. First, this is a sine function, but there's a couple of things wrong. So the first thing you have to look for is you need to find the midline. It goes up to 1, but it goes down to -3. So we need to find what that midline is. We need to find the average, which is -2/2, which is -1. That means at -1, that is actually the midline. Again, the midline cuts the graph in half from the top to the bottom, which means we know that it moved down 1. Wherever the midline is, that is the vertical shift. That is the vertical shift. Now we can see if there's an amplitude. So from the midline, it actually stretches up 2 and it stretches down 2, which means I know that's a 2. Now we also know that instead a sine function starts at 0, 0, or in this case, it moved down. A sine function normally goes up and then down, but this time it actually goes down first, which means that must be a negative. And now the last, we need to check the period. So a sine function, this sine function goes down, back up, and down again. That's the starting point. And look at the starting point, 2 pi, which is exactly what it's supposed to be. So that should be a 1. So it should be a -2 and then a -1. So -2 minus 1. And it worked. So let's do one more to check that midline. Cosine is the normal graph, but this graph goes down to a -1 and it goes up to a 5. So first thing I'm going to do is find the average. -1 plus 5 is 4, divided by 2 is 2. That means that is the midline. This is the halfway point. And so since that's a 2, that automatically becomes the vertical shift. Now, in a cosine function starts at the top and goes down, but this cosine function starts at the bottom and goes up, which means I know there's going to be a negative in front. I also know from this midline, it stretches up 3 and it stretches down 3. So I know that's going to be a 3. The last thing we're going to check is the period. So this starts down here, it goes up and then back down. This is the new starting point, and that happens every 2 pi, which is what it's supposed to do. So it's going to be a 1. If that number was not a 2 pi, like say if it's another number, then you would set the formula equal to that number to figure out what b needs to be. So our answer should be -3 and then a +2. And let's see. And that was correct.